Because science really deals with facts. They're facts and they're governing principles that tell us how physical reality works. It's never 100% certain. I already gave you the uncertainties on that global climate record, but neither is everything else. How do we develop science? We develop it first by observing the real world. We develop it by experimenting, perhaps less so in this field of climatology than some other fields, but nevertheless we can do some experiments, and I'll describe those later. We theorize. We publish in peer-reviewed literature, which means we publish something, we write a paper, the editors of the journal we send it to send it out to several scientists who review it, who assess whether the science is correct, who make suggestions for changing it. The paper is published if it's deemed suitable. It's published in the literature. Other scientists read it. They can try to duplicate the results, or they can show that these results are incorrect. And so science is a very self-correcting process. And after a while, when observation and theorizing come to a consistent picture of what's happening in the phenomenon under study, then a scientific consensus tends to emerge. And so in that consensus, science can be quite certain of sort of big picture ideas, the whole grand scheme, without necessarily knowing every detail. And I want to emphasize that because that's certainly the state today of climate science. We certainly know the big picture. We know that Earth is warming. We know why Earth is warming. We know, as I indicated, and as I'll describe in the second half of the course, that at least some of that warming is caused by human activities. We know the big picture. We don't know every detail. Not knowing every detail doesn't negate our knowledge of the big picture. And there are plenty of other areas of science where you can think of that also. One example is evolution, where we understand the big picture about how species evolve, but we don't necessarily know every detail of every mutation that caused one species gradually to evolve into another. But we do understand the big picture, and that's the state of climate science today. There are plenty of uncertainties, there are plenty of things we still need to understand, but we know the big picture. Now, there's another issue, and that's public policy. Public policy is about what the public ought to do about many factors, including scientific knowledge. How should we respond to our understanding of what Earth's climate is doing, for example? Now, science can certainly guide policy, but science isn't about policy, and some scientists stay meticulously away from saying anything about policy. Other scientists will happily use their scientific knowledge to jump in and give advice to policymakers, political leaders, business leaders, and so on. That's sort of a personal choice for the scientists. Once the scientist steps outside the realm of science, he or she is then giving his or her opinion about policy. That's a different thing from science, because science is this consensus-building, corrective, peer-reviewed procedure that arrives at a common understanding. Policy is based on many other things, including values, political judgments, and so on. So science can guide policy, but science alone can't determine policy. Now, the content of this course, certainly more than any other teaching company course I've done, and certainly more than most courses I teach at Middlebury College, has significant implications for public policy, in a way that, for example, the Big Bang theory of the origin of the universe, at least at present, seems not to. It may have important consequences for how we think of our place in the universe and so on, but it doesn't have immediate policy implications. Climate change does. Because to the extent that climate change is caused by human activities, then what we choose to do can affect future climate. That situation has led to a kind of muddling of science and public policy. A lot of muddling in the mind of the public, a lot of muddling in the media. Some of the muddling has been intentional, some has not been intentional. It's raised a lot of questions in the minds of policymakers and of the public about climate change. And I don't want to get into questions of policy. That's not what this course is about. What I'm going to be dealing with is the science of climate, and my job is to explain to you why we understand what we do about Earth's climate, about its changes, and about the causes of those changes. So I'm not going to get into the policy issues. I'm not going to recommend what we should do, although at the very last lecture I'll give some suggestions about what future climates might look like depending on certain paths we might or may not choose to take. But this is not a course about policy. I'm not advocating policy. I'm sticking with the results of that peer-reviewed, consensus-building, theorizing, experimenting, observing aspect, which is science. The course comes in basically two halves. It's a 12-lecture course, and it basically comes in two distinct halves. The first half is going to deal with our basic scientific understanding of the climate system. We're going to look at past climates. We're going to look at principles that determine climate. And let me pause here a minute and give you a brief outline of the first half of the course then. Okay, so here's the first half, part one, the first 6 lectures. The first lecture we've just come near to the completion of, is Earth warming? Raised that question, is Earth warming? And answered it basically in the affirmative. Earth is warming, has warmed over the last 100 years or so by most of a degree Celsius, by a little more than a degree Fahrenheit. So we've taken care of that question. Lecture 2, butterflies, glaciers, and hurricanes. Why? Because it isn't just rising temperatures as indicated by thermometers that tell us what's happening to Earth's climate. So do things as diverse as the way species are behaving, butterflies are an example, the way glaciers are behaving, most but not all of them are melting, and the way hurricanes are behaving, some of them are getting more intense. What does that have to do with climate change? Well, those may all be additional indications of climate change. Lecture 3, Ice Ages and Beyond. Unfortunately, this thermometer temperature record can only take us back to the mid-19th century. And if we want to know whether what's happening to Earth's climate now is abnormal or maybe just some natural fluctuation that will stop in a few decades, we need to know what Earth's climate has done in the more distant past. So we'll go way back. We'll go back into the Ice Ages. We'll go back first 1,000 years or so. Then we'll go back into the Ice Ages, hundreds of thousands of years. And eventually we'll take a quick look all the way back 3 billion or so years to the beginnings of Earth's history. So we'll be looking at climates in the past in Lecture 3. Lecture 4, in the greenhouse. You've heard of the greenhouse effect. The greenhouse effect is crucially important for understanding why Earth's climate is the way it is, not only naturally, but if there are also human effects on it. So we'll look at the science of the greenhouse effect. In Lecture 5, A Tale of 3 Planets, we'll look at our evidence that this theory of the greenhouse effect and its role in climate is correct. And we'll end the first section of the course with global recycling, a look at how the Earth recycles materials, particularly water and carbon, whose recycling is crucial to understanding how climate develops. That's the first half of the course. The second half of the course is more about the human influence on climate. So in Earth Changing Climate Part 2, we'll start with Lecture 7, The Human Factor. We'll look at what we humans are doing in the context of the science that I described in the first half of the course, and we'll see how some of the balance that gives us the natural climate is being upset by changes we humans are making. We'll talk about computing the future. How do we project, not predict because it's not that accurate, but how do we project future climates? How do we understand what future climates are going to do? How do computer climate models work, and so on? We'll look in Lecture 9 at the impacts of climate change. What is climate change going to do to the planet besides the obvious, which is warming things up? What are some of the other impacts? Sea level rise, changes in the way species behave, changes in precipitation. What are some other impacts of climate change? And then we'll move in the last 3 lectures to energy and climate issues, because it's the human use of energy that far more than anything else is what's causing human beings to alter nature in a global sense for the first time, and in particular to alter the climate. So we'll look at energy and climate, that link. We'll look at the resources we have to make energy for ourselves here on Earth and what some alternatives are to what we're doing today. And in Lecture 12, we'll raise the question, can we see our way to a sustainable future with a stable, benign climate? So that's an outline of where we're going in this course. Now, there are a few other resources available to you that I strongly urge you to take advantage of. At the end of each chapter in your booklet, at the end of each lecture, in your booklet, there is a list of suggested readings, and I've chosen to break out the suggested readings into 2 different types. There are the suggested readings that you really ought to go into to remind yourself what this is about, to get corroborative evidence from other authors, and so on. And then I've given you a section of readings called Going Deeper, where I give you books and occasionally scientific papers that go deeper into the issues I've discussed in that particular lecture. And if you really are interested in looking quantitatively at the science behind those things, I urge you to look at those. We get an awful lot of our information today from the World Wide Web, and so at the end of each lecture, I also give you websites to visit. Some of them are websites that give you more explanatory material on what I've covered in the lecture. Some of them are the websites that give you the raw data that I've used. If you wanted to make that graph that I showed you at the beginning of this lecture of Earth's global temperature, I'll show you what website to go to that publishes that data, makes it available to the public, and you can go ahead and use that data yourself. A final reason for looking at the websites is that everything I say here is frozen in time as of the moment I'm making this lecture. Those websites can update that material and keep you very much abreast of what's going on in this rapidly changing field. So I hope you'll enjoy the rest of this course.